Okay, in this video, we're going to work on the similarity, and we're working on 6.1 similar polygons first. Okay, so it says use the similarity statement to the right to identify all pairs of congruent angles. Here's your similarity statement. This is huge to work with, especially in this situation when the orientation of these two triangles are different. So I'm not even going to look at those triangles because that will just confuse me. So I'm going to identify all pairs of congruent angles by matching up the angles with the congruency statement. So R equals W, S equals V, and T equals U. And I know I have it correct because I worked with the similarity statement. I'm going to do the same thing for the ratios. So remember, in similar shapes, the angles are always congruent and the sides are in proportion. And that proportion is the scale factor. So those are all the pieces we have to keep straight. Okay, so it says write the ratios. So I'm going to take the first two letters over the first two letters, the second two letters over the second two letters, and the first and last over first and last. And we're done. Okay? Going to the next one, it says use the similarity statement on the right to find the scale factor of the polygon on the left to the polygon on the right. Present the scale factor in simplest terms and keep the scale factor a fraction. Okay, so let's see what we have. In the shape to the left, I only have one value, and that's 21. Those are the first two letters. Match up the first two letters over here, which is our X, Y, and that's going to give me 35. So 21 over 35 is my proportion. Now, both of these numbers are divisible by 7. 7 goes into the numerator 3 times. 7 goes into the denominator 5 times. And my scale factor is 3 to 5. And that's the reduced form. Next, use the scale factor and the similarity statement once again to find the length of SV. Okay, so SV is to what? SV is first and last. So that means it's XY, XW. That's going to equal 3/5. Now, I don't have a value for SV. I'm looking for that. But do I have a value for XW? And yes, I do. So I can do the following. I can erase my denominator, and I can replace that with the 20. Now I have fraction equal to fraction. This is where I do cross products, okay? So I'm going to say 5 times the value of SV equals, and that's 3 times 20, which is 60. Divide both sides by 5, and you get SV equals 12. That length is 12, okay? And that completes 7. Now let's go on, and we're going to do, so far we have done, let's see, we've done 6, 7. Why don't I go ahead and do 8? I may even do 8 and 9. Okay, let's talk about 8. So 8 says I'm going to use angle, angle, side, angle, side, and side, side, side similarity. It says determine whether the triangles are similar by using any of those, and identify which method you use. If the triangles are similar, write a similarity statement. That will go right here, okay? If the triangles are not similar, check the line indicating this, and then leave the other questions unanswered. Okay. Look at this first situation. I have only angles. So I need to have angle-angle similarity if these shapes are similar. I have no information about the sides. I can't make assumptions. In both situations, I have a missing angle. So how many degrees are inside a triangle? 180. do your math, and I'm getting 31 degrees here, and I'm getting 47 degrees here. Now, do I have two angles that are the same between those two triangles? So look carefully. I see that I have a 92 both places. Do I have anything else? And you should be saying, no, I don't. Since you don't, you can't use angle-angle similarity. That's your only option. So we're going to check triangles are not similar, and then we don't write anything here or here. Okay? Move on to the next one. Look at these shapes. I have no information about angles. The only thing I could do is try to do side, side, side. So for that to be true, I'm going to have to look at my proportions. What are my proportions? Take the smallest value on the left, that's 8, put it over the smallest value on the right, that's 16. Then go to the medium. Okay, this is the baby bear, mama bear, papa bear problem. Go to the median, which is 10, and the middle number on the right triangle, which is 20. And then go ahead to the large one on the left and the large on the right. For us to have similarity, each of these have to be equal. Well, I look at that and I say, oh, wait, this is 1/2. Oh, that's 1/2. And that's 1/2. So they all have the same scale factor. Their sides are in proportion. So the triangles are similar by side, side, side. Now you have to write your similarity statement. So to do that, you're going to say, okay, let's look at this. I'm going to go down the small and across the median. So triangle down the small and across the medium. That gives me triangle ABC. That is similar, do the same thing. Down the small, DE, and across the median, which is F. That's your similarity statement. Okay, and we did not fill in that line because they were similar. Okay, the next one. Look at these two shapes. This is 90 degrees. This is 90 degrees. I only have one angle, and I only have two sides. So I have to be looking at side angle side to prove these two shapes are similar. So let's think about this. In order to have side angle side, the angle that's sandwiched between the two known sides has to be the same in both cases. That is true. Then I have to do my proportions. Is it true? And I'm going to say small in the left triangle is to small, just like, this is going to be a question mark, medium is to medium. Well, this is the situation for cross products. If these guys are equal, then we can say yes, the sides are in proportion, the angles are equal, and I have side angle side similarity. So 4 times 9 is 36. Does that equal 6 times 6? That's also 36. That checks. The triangles are similar by side, angle, side. Now I have to write my similarity statement. So I'm going to go down the small to the angle in common and then up the second valued side. And that's similar to go down the small to the angle that they have in common and then up the other known side. And that's my similarity statement. Okay, we only have one more problem in this chapter, and that's proportionality theorems. So we're going to do that in this video as well. So let me just turn to the right page, and we'll talk about this problem too. Okay, so a couple of things are going on that you want to notice. Number one, if these sides are parallel, then what's going to happen is the following. Once I see that, and let's make this value x. The fact that those are parallel allows me to write this proportionality. X is to 5, just like 12 is to 6. See what I did? Look at where I'm pulling these numbers from. Here again, we have cross products that's going to let us solve for X, which is my length of AB. So doing your cross products, you get 6X equals 5 times 12 is 60. Divide by 6, divide by 6, and we're getting X equals 10. So AB's length is 10, and we have completed the chapter.